Hello, everyone. Thank you for joining us. We will get started here in the next couple of minutes. Good afternoon, everyone. I'm Laurel Aragona from Smith & Nephew, and I am one of the Body Art Committee chairs. We'd like to thank you for joining us for the AFTO Professional Development Series. And we are here today with Christina Blasi and Understanding Safe Materials, Reading Mill Certificates, and Recognizing Red Flags. We will be taking questions at the end, so feel free to hold on to your questions or type them into the questions box during the presentation, and we'll read them out at the end. And this webinar is being recorded and will be available for viewing at a later date. So now I will turn it over to Christina.
Hi, everyone. My name is Christina Blasi. I'm the current legislation liaison for the board of the Association of Professional Piercers. I'm also a full-time piercer and owner at Piercing Experience in Atlanta. This presentation is modified from one I gave for the APP's annual conference a couple years ago. Safe materials matter to both piercers and inspectors. So what we're going to be talking about today is what quality materials jewelry should be made out of, how to know that that's what you're dealing with, and what should be avoided. So the thing with jewelry material is that can cause problems for customers, various bad reactions, so we want to make sure we're really giving people what they deserve. So that's why that matters. Poor quality materials can have toxins in them. There's been studies that have found costume jewelry from various regions that have things as bad as lead and cadmium in it. Materials can also cause allergic reactions in sensitive individuals. So we try to avoid materials that have high levels of known allergens like nickel. Low quality materials can also corrode inside the body and can cause scar tissue and inflammation. One of the most common adverse reactions, like I was saying, was contact dermatitis from nickel being released by cheaper materials. That's why in Europe for the last, I think, over a decade now, there has been strict controls on what a level of nickel jewelry can have. That's not something we control as much in the US, but as you can see, this is something that definitely can cause problems. Low quality materials can also cause excess scarring and immediate inflammation, as well as corrosion. These are pieces of jewelry that colleagues have taken out of their customers. So this stuff is on the market. We want to make sure we are avoiding that at all costs. So that brings us to, what do we want to look for? What is a sign that something is well tolerated? There isn't a single material that works for every single person. Yeah, everybody's chemistry is a little different. That's why, some people are allergic to something like peanuts and some people aren't. But we do have test methods to find materials that have the best known reactions in the body. Yeah, this is stuff that the medical community has studied for things like orthopedic implants, bone screws, that kind of stuff. So we have evidence of how these materials react in the body. There's no reason for us in the piercing community to reinvent the wheel. This is something that there are constantly studies, trying to make the next best biomaterial for specific applications, stuff that's easier to produce, et cetera, et cetera. So, we want to go with known entities. For piercing, we do have some specific requirements. We want these materials to look good. Some of these things that have been developed for medical applications are dull or ugly color or something like that. So, piercers aren't going to want to make jewelry out of that. Additionally, since piercings have a interface between the inside of the body and the outside of the body, we have kind of a unique environment. These are pieces of metal or other materials that get exposed to all kinds of chemicals because of all the personal care products people use. During healing, they're in direct contact with the bloodstream as well. So we need to take into account how these materials respond to that environment. They also can get scratched or damaged from everyday wear and tear. So we want to make sure that that's another selection criteria that we are taking into account when selecting a biomaterial for jewelry. Most studios want to consider expense too. So something like platinum that would be used in heart stents, might not be something we can make everyday jewelry out of. Yes. So we refer to standards for implant because, again, this is something that the medical community has already studied. They've already done the expensive testing, the long-term standards. They have the science to back up these materials. And the biggest governing bodies that create these standards are the ASTM, which is the American Society for Testing Materials International. This is a consensus-based organization that has members in all different fields to come up with standards for everything from toilets to medical and surgical devices. There is the FO4 committee that specifically deals with biomaterials, which I'm actually a member of. So, as new materials come under review, everyone on the committee gets a chance to comment on these standards, to see the evidence for or against it, and to decide whether to adopt a new material. Standards are also regularly reviewed. So like the existing, say, standards for titanium, if there are new studies that show good or bad data for that, again, it comes up to the committee and they make minor revisions as necessary. Internationally, you'll also see ISO, which is the International Organization for Standards. It's very similar in structure to the ASTM. You'll see this more commonly in jewelry from Europe or Asia. But most ASTM standards have a sister standard from the ISO. And ISO also has a generic standard, which is ISO 1099, that covers blanket standards for biocompatibility. Excuse me. So the ASTM standards have five overall sections. The most important are going to be chemical requirements, which is basically the recipe. The mechanical requirements, which include things like, how strong the material is, what its hardness is, that kind of stuff, and if there's any other special requirements. So we're going to go over how to read these standards. So this is the standard for 6-4 titanium, which is ASTM F136. This is the introduction to this. This is probably the most common reference standard you'll see for titanium for body jewelry. Again, that's ASTM F136. So yeah, as you can see, it tells you like the scope. So each standard will tell you what that material is supposed to be used for, like how it's produced, etc. It tells you all the references in terms of how it's created, how it's tested, etc. Any other definitions are in there. The next section in an ASTM standard is the chemical requirements. This is basically the recipe for how to get the right chemical constituents in your material. This is important because these are both minimums, maximums. Some materials, it's the ratio of one material to another that gives you the right reaction in the material. Sometimes there's just basic maximum, like materials you don't really want to see will have a maximum level that it can have in it, to make sure that those contaminants are not causing problems. Anything that has more contaminants than the allowed chemical requirements would not meet the standard. Other things, things like dissolved gases, like the nitrogen and hydrogen and oxygen, can also lead to problems with the mechanical requirements or microstructure, which we'll get to in a minute. So depending on the exact material you're talking about, you'll see, like some things will have a maximum, some things will have a minimum. That's all going to vary depending on like how those chemical constituents interact with each other in the material. And this is where, when you get test results for a material, you want to see that the chemical requirements match up to this recipe. So next section of an ASTM standard is the mechanical requirements. These requirements are not as important for body jewelry in general, because we're not worried about, hip replacement breaking or something like that. Generally body jewelry is not subjected to the harsh conditions that an orthopedic implant would be subjected to. But technically, if a material does not pass this section of the standard, it does not meet the standard. So that's something to be aware of. And many biomaterials will also have special conditions for microstructure. This is how the atoms are arranged inside the material. This is important for biomaterials because if the microstructure is not correct, it can affect things like corrosion resistance, which we don't want biomaterials corroding. It can also affect how small contaminants are released into the body, depending on how they are contained inside of other atoms. So again, that's something you'll want to see when reading a mill certificate, that the material passes the requirements for microstructure. Like this is, again, ASTM F136, which you can see in 9.3, you can't have alpha microstructure. If that's detected in the material, that would disqualify it as an ASF 136 titanium. So the APP standard is not technically an exclusive standard. The way the APP looks at jewelry standards is, it will accept any material that meets standards for human implant. But with thousands and thousands of materials out there, not all of them are commonly available to jewelry manufacturers. So we give a list of example materials that are commonly found, but if a manufacturer wanted to start making jewelry out of another material that met standards for human implant, for instance, there is a titanium alloy called F1713 that is a slightly different alloy that contains niobium. That would be accepted by the APP, but it's not something that's currently on the market. We want to be able to accept new materials as they become available, because there's, some materials, have certain advantages, like this titanium 1713 has the advantage of being able to be anodized black, which is something that a lot of folks want for appearance sake. And that would be a safe material if a jeweler wanted to start using it. But most commonly, you will see F136 titanium, as I said before. One of the major manufacturers has also started using F1295, which actually in some ways has a little bit more biocompatibility than the F136. ASTM F138 steel is going to be the most common steel alloy you'll see made into body jewelry. There are other steel alloys that would be acceptable, but I'm not aware of any manufacturers actually using that. We will also, as an organization, accept pure niobium, which does not have an ASTM standard because currently it is not a material that is used by itself as a biomaterial. We will also accept solid 14 karat or higher gold that is nickel and cadmium free, or polymers that meet the ISO standard. Again, currently no one is making jewelry out of implant grade polymers, but that is something that if someone wanted to do it, it would be okay. So, you see all these words, like how do you know what you see in someone's jewelry case is actually this implant grade of jewelry? Because it's not something, you can really tell by looking at it. So there are two major types of ways to test a biomaterial. There is what's called destructive testing, where you actually take a piece of the metal and do a chemical breakdown. That's going to give you an exact breakdown of what's in there. You can look at the microstructure. You can see everything that's in there. The problem with that is you have to look at the finished product, and as it says, you are destroying it. So that's not something you can do on a piece that's going into somebody, because you have to destroy it to test it. That kind of defeats the purpose. So that would only give you like random samples. So you could have, a lot of material that parts of it are okay and parts of it have contaminants in it. But if you're only randomly sampling it, you could miss those contaminants. This is also something that's an expensive testing method. And generally jewelers are not going to have the required laboratory equipment to do it themselves. So what's more commonly done in the production line is using non-destructive testing, like X-ray diffraction. That's basically a little X-ray gun, like if you've seen someone use the like infrared thermometer guns. It's kind of a similar but larger piece of equipment. Some manufacturers can even integrate it into their production line to scan items as they go through production. So it's very easy to check. You could technically you could check every single piece with non-destructive testing. The problem with non-destructive testing is there are some impurities you cannot detect with non-destructive testing because it will show up as the same same values as the constituent materials. Like for instance, with titanium, you cannot tell the difference between titanium and tungsten impurities with non-destructive testing, which is how you end up with pieces like this. This is a piece of jewelry that a piercer received from a manufacturer who claimed it met Astm F136 standard. When they tried to anodize it, which is an electropolishing process, chunks of the barbell flaked off. This was because pieces of tungsten from the electrode and the smelting forge had contaminated the titanium. So this is something that the supplier swore met standards, but visibly pretty quickly showed it was not what it was supposed to be. This is why you cannot you cannot just rely on non-destructive testing, because this is and this is something that has led to recalls of orthopedic implants also. This is where you get into what's called Dfar's compliance. This is a fun one to try to explain. So Dfar's is the Defense Federal Acquisition Regulation Supplement. This is basically a agreement between our military and other countries to follow strict standards of quality control in producing equipment. It originally started with military equipment like armaments and things like that. But it has also been used for medical equipment, because countries that are in this agreement agree to follow strict enough standards that we can be pretty sure that their factories are doing the quality controls they need to prevent these kind of impurities from getting introduced into the materials. The other part of this agreement is that if countries are passing off false certificates or falsifying data about what they're providing, there are consequences. They can basically get kicked out of the agreement if they're found to be giving fraudulent data. Because this is an issue, because we can't do destructive testing of every single piece of body jewelry. We need to have some way to know what we're getting is what they say on paper. It's something that has come to even the attention of the World Health Organization. That certain countries manufacturing plants for this material are not following guidelines, and contaminants can get introduced. And once the contaminants are introduced, you can't get them back out. So currently there are something like 20 something countries that are part of this agreement, including most of Europe, as well as Japan. So it's not just U.S. mills that we can trust. This is something that the government updates the list of every year. As countries want to become part of this agreement, or there are problems with countries. Yes, thanks, Brian. But this is something you can look up online as the list changes. So this is where we get into mill certificates. So a mill certificate is a piece of paper provided by the mill that produces the raw material. and it should have all of this information on it. You should know exactly like who received the material, what mill it was provided from. Both of those should be on there. It should tell you what standard the material meets. It should tell you what form the material is in. So for instance, body jewelry manufacturers are going to buy wire in various sizes to make barbells and rings and things like that. They are going to need to have a certificate for each size wire they receive, as well as other forms for things like making barbell balls or larger pieces like eyelets or something like that. It should also include how much of it received. It's a pretty big red flag if you see a very small amount of material on the certificate. Yeah, if the certificate only covers a kilogram of material, that's not going to make a lot of barbells. The other important things to see is it should have a heat or code or number. This is like basically like a batch number so that you can trace like which lot of material it came from, and it should show you the breakdown of the chemical analysis. So here is an example certificate. So it tells you which manufacturer it received, what date, has a heat number at the top there, tells you what material, what standard it met, tells you what size. It tells you like what the chemical breakdown is, the mechanical properties of it, what country it came from. That's something that's very important to see. So if you're missing any of these kind of things, again, that's a red flag. Some companies will try to claim that information like this is a trade secret because they want to feel like, you know, they have some secret source for their material. You know, there's really not a ton of mills that are making material that meets these standards, so it's not really a secret. But yes, like Fort Wayne is one of the big ones. You know, that's all good things that we want to see. All right. Yeah, so here's here's one that's a little bit less in depth. You know, it's missing the heat number, so we don't know what batch this is from. It doesn't say exactly how much is in here, and it doesn't expressly say what country it's from. So this one you might want to go back to the jewelry manufacturer and ask for more detailed information, because it is definitely something that they can provide. So here's a certificate that we have seen circulated from a lot of companies that's very suspect. It doesn't include any of the things that we're looking for. It's just a chemical breakdown. So like it could definitely have those tungsten or other impurities in it. We don't know that it meets mechanical specifications. We don't know anything about microstructure. It's only 14 kilograms, which is not very much. All of those, are a big red flag. So if this is what a jewelry manufacturer is providing, that means that this is not a compliant certificate. So again, we can't just test the final product instead, because the only way to get a full breakdown would be to destructively test it. So you can't destroy something to test it and then put it in somebody. That's just not practical, and it doesn't tell us anything about the quality assurance of the actual production of the raw material. So here's some common materials that we see. Like I said, this is the difference between titanium F136 and F1295. You can see the big differences. Instead of the vanadium, the 1295 uses niobium and tantalum instead. Otherwise, it's pretty similar. This material was developed because there are some individuals that are sensitive to vanadium, so they wanted to develop a material that did not use the vanadium, but gave similar mechanical properties. So this is something that we are starting to see in the body art industry. There are titaniums that are not implant graded, and there are common, quote, surgical steels that are also not implant grade. One of the things you'll see some manufacturers kind of brag about is jewelry that's G23, which is grade 23, or ASTM B grade materials. So these are standards, but these are not implant standards. They are standards for things like aerospace and other industry, which is fine for their applications, because they're really just worried that something's not going to corrode or something's going to be strong enough, to keep their plane afloat. But this does not have any kind of requirements, for the level of lack of impurities that we need for a biomaterial. So again, you'll see folks that think they got something good because their manufacturer's like, oh, we have G23 titanium, that's the best. I mean, it might be the best for aerospace, but it's not what we need for human implant applications. And again, here's kind of a difference, but between 316 steel and ASTM F138 steel. Yeah, as you can see, the chemistry is very similar. The thing with F138 is there are stronger requirements for mechanical properties and microstructure. And again, any mill that claims they're making F138 that's in a compliant country has to meet stricter standards for quality control during production. And another standard you should be aware of is ASTM 2999, which is a general safety standard for adult jewelry. This does cover body jewelry as well as standard jewelry like rings and necklaces. It does say that body jewelry should meet basically the standards we've been talking about. But it does make an important distinction between wearing surface, which is the part of the jewelry that goes inside the body that has more direct contact with your body chemistry, and pieces that are on the outside. There's also a similar standard for jewelry for children. All right, what other red flags should you be looking at? That are a pretty good sign that maybe the jewelry you're seeing is not implant grade. Right now, there is not any jewelry on the market that is externally threaded, which we'll talk about in a minute, that is made of implant grade materials. If you see jewelry that's just poorly made overall, no one's going to invest in really good quality material and then cut corners on things like how polished it is. They're not going to use super cheap gemstones. They're not going to plate things. So externally threaded jewelry is when the threads of a barbell are on the post and the ball has a hole that is tapped. The biggest problem with this, which is why the APP stopped allowing it years ago, was you are required to push the screw threads of the barbell through the piercing, which can cause significant damage because it's sharp. The tolerance between the threads on the barbell and the threads in the post are often not that good either, which, as you can see in this example, you can see biomaterial in the threads. This is something that can cause, just could theoretically lead to infection because you've got more germs sitting on your jewelry. That's not something we want. And again, like there is not anyone making jewelry of implant grade materials that is using external threads. It's just not something that, you know, anyone is going to use an inferior manufacturing process with good quality material. Unfortunately, you will sometimes see 14 karat gold jewelry made by jewelers who don't understand body jewelry with external threads. Yeah, that's where you have to see if like your local regulations have any restrictions on this. Anyone that's specializing in body jewelry is not going to make 14 karat gold jewelry with external threads because of the inferior fit, but it is something you may see from time to time. You also want to make sure you're watching out for jewelry that's plated. That's something, you know, those of us in the industry see pretty regularly, where people are having a hard time with stuff that they bought online that said it was titanium, but it's really just plated, and you're seeing, you know, pieces of plating flake off. You know, you'll see a lot of jewelry that's 14 or 18 karat gold plated as well, but you know, that substrate material is not good quality. You know, you can see corrosion. Yeah, it is just not something that holds up well. Yeah, inside the body with, yeah, the body fluids that are exposed to, it's something that's just not acceptable. With quality jewelry, you'll also see higher quality gemstones. You know, you're not going to see much of these like low quality foil back crystals that like turn black over time. The gems are going to tend to be what's called hardware set, where the actual metal of the barbell is holding in place. It's not glued on. Because manufacturers want to have pieces that are going to hold up over time. All right. That's really all I have for this. So I guess we've got some questions.
Yes, sorry, it took me a minute to find my yes, so one of the questions is, does the ASTM standard F136 include a list of unacceptable materials like lead?
Anything that is not on the recipe is not accepted.
All right. Another question is China on the Dfar's compliance list?
It is not currently. That is where we see the most non-compliant certificates from. They could decide to become part of the agreement, but it is not. They are not currently on the list.
All right. Another question is, I'm new to this field, so what documents will facilities have to provide to ensure that jewelry for body piercing is safe?
Mill certificates for anything that's titanium or stainless steel, which is what we talked about in this presentation. With gold alloys, there's not as, it's a little bit different, but gold alloys can have SDS sheets, which is a chemical breakdown. That's something that some jewelers will provide. Gold can be difficult though, because some manufacturers are mixing their own batches of gold. If they're smart about it, they're gonna have each batch chemically tested so they can show that they don't have things like lead or other contaminants in it. Gold purity is regulated by the FTC, the Federal Trade Commission, but it does not regulate contaminants. It just says that like 14 karat gold has to be 14 out of 56 parts gold, or 14 out of 24 parts gold, which is 56%. I think that answers that.
Okay. And then another question along those lines is, how do you match a mill certificate with the actual jewelry when you are in the shop?
Some manufacturers have started putting batch numbers on their invoices, and have their mill certificates either emailed to their customers or available on their website or a private portal. Like I try to download all my mill certificates from my manufacturers at least once a year. Or, sometimes, like I said, I'll get an email and they'll say like, oh, hey, we just posted new mill certificates. That's something that, because we are not dealing with like medical devices, have to have a paper trail that shows that like this serial number of hip replacement is from batch, whatever of raw material. For recall purposes. That's not something we have to deal with. Well, that's not required in body jewelry. But you should see invoices from body art studios that show how much jewelry they're ordering, and they should be able to get mill certificates from their manufacturers from the same approximate time.
So also along those lines, so if the piercer orders multiple pieces of jewelry from one supplier, will there just be one mill cert, or a mill cert for each piece?
It won't be a mill cert for each piece. There will be a mill cert for each like size of raw material. Like for instance, with barbells, if a manufacturer is making 16 gauge, 14 gauge, 12 gauge, and 10 gauge barbells, they should have a mill certificate for each of those sizes of jewelry. And they'll also have a mill certificate for whatever shape raw material they're making, like things like gemstone ends or barbell balls out of. So there's definitely going to be multiple certificates for any manufacturer.
All right. Somebody asked if you could repeat what information should be on the certificate.
Let me go back. Is that on this one? So this is what should be on the mill certificates. The contact information for the mill, as well as the contact information for the person who purchased, for the jewelry manufacturer that purchased it, what ASTM designation that material meets, the raw material size and dimension. Like I said, like if it's 14 gauge wire, if it's 1/2 inch by 1/2 inch ingot, and it should give you a quantity either in number of pieces, or more commonly it'll have a weight, like it'll say 100 kilograms or something like that. It should have a heat code number, so that's like the batch number, and it'll have the chemical breakdown.
All right, great, thanks. Another one is, so is there a list somewhere of mills that are approved or have been the subject of complaints?
There's too many. That's that's where the country of origin is important on your mill certs. If it's a country that's in the Dfar's agreement, it should be okay. The other thing is some mills create some material, in multiple countries. So that's where you want to see, where exactly the material came from.
All right. Another question is, in Florida, new piercings have to meet this standard, but shops may have other jewelry which doesn't meet this standard. So is there so it's hard to match the mill certificate with the specific jewelry. Is there a way that you suggest doing that?
I mean, that's something the APP has had to deal with. I mean, unfortunately, like, if you allow studios to sell jewelry for healed piercings that don't meet the same standards, you kind of have to have an honor system for them not putting the jewelry that doesn't meet standards for new piercings into new piercings. Yeah, that's why, like, I went over things like external threading and things like that, so you can have some visual clues as to what is a quality piece of jewelry versus a not quality piece of jewelry. Like, yeah, that's something that you can develop an eye for over time. Like, I can take a look at a barbell ball and tell you what manufacturer made it, because their countersinks and things look a little different. But yeah, as an inspector, like, that is difficult. But yeah, like, if you see something that's externally threaded, it doesn't meet the standard, because that's not something that's available right now. If you see any of the other red flags I mentioned, see what, that it doesn't look, it's not polished mirror smooth, that's something you might want to try to dig a little deeper. If you see, like plastic looking, cheap looking gemstones, that might be something to dig a little deeper. And just like with the mill certificates, that you want to see that they're ordering large quantities. Like, that's something you want to look at with studios invoices, like making sure that they're ordering enough quality jewelry for the amount of piercings they're doing. Because if they're only ordering 5 quality barbells a month, they're open 7 days a week, that's a pretty good sign that they probably are passing off poor quality jewelry for their customers.
Right. And I guess that is how you could tell if somebody is providing a fake mill cert as well.
Yeah, that's why the mill certificates need to have the jewelry company's name on it, because that you should be able to match up to invoices.
Okay, awesome. Another question is, I've had the same cartilage piercing for over 15 years. Is there a known life expectancy for the hoop, and or should I have it replaced after a certain time period?
With a quality piece of jewelry that hasn't gotten physically damaged, that's shouldn't be a problem. Yeah, that's one of the reasons why we chose to use material that meets standards for a long-term implant or permanent implant, so we know it's not going to break down over time. The issue with body jewelry, though, is sometimes it gets physically damaged. Like, if it gets scratched or something like that, even if the material is still technically good quality, if you've got a piece of jewelry that's got a sharp edge that could scratch your piercing, you would want to replace it at that point. Yeah.
All right. Are there any specific requirements for jewelry that is not for initial piercing?
That comes kind of into, we're at your own risk territory. Like the APP is, advises against wearing jewelry that meets, that has contaminants in it, like, lead and things like that. But, some people can tolerate certain materials better than others. You can be sure that anything that meets, the long-term implant standards is safe. Anything else, you don't really know how it's going to be tolerated inside the body.
All right. Another question is, could you go over again the difference between 316 LVM and ASTM F138, and why the 316 LVM is not permitted?
So the main difference between ASTM F138 and 316 is the mechanical properties and microstructure of the material, which affects how contaminants like nickel are released into the body. With the ASTM F138, it's supposed to form a chromium oxide layer on the outside of the whatever it is, what jewelry, implant, whatever, that's supposed to contain the nickel inside the material to prevent it from leaching into the subject's body. Because that's why you have to have the stronger quality controls and how the piece is produced and how it's finished. The thing is, even with ASTM F138, that layer can be damaged by like if it gets scratched, and that can create a higher release of nickel like inside the body. That's one of the reasons why a lot of studios have stopped carrying implant grade steel items, because that is something that can happen.
All right. Another question is, in this person's state, mall kiosk ear piercing places are often exempt from regulation, and therefore they use whatever. And they're wondering if you've seen that around the US.
Oh yeah. I am glad that NEHA has made a stance that ear piercing guns and establishments that use them should meet the same standards as other body art establishments. But once you put something inside the body, you put something inside the body. Like, I don't think there should be any reason to have a lower standard for those folks.
All right. And another question is, what do you suggest for places that don't check mill certificates for those inspectors?
I don't know. I don't know if it would make sense for your health department to maybe make a list of manufacturers they accept if they're not going to look at mill certificates. The thing is, like, without a paper trail, like, there's no way to know exactly what you're looking at. Like the Association of Professional Piercers keeps a list of manufacturers that they are comfortable with accepting from their membership, and they keep a list of mill certificates from those manufacturers, so that they know, when someone submits an application that they're selling jewelry that meets the APP standards. And that's something that if they see a manufacturer that they haven't dealt with before, they reach out to the manufacturer and make sure we get the documentation necessary. That would be the other way to handle it. But without having a paper trail, you just can't be sure what you're dealing with.
All right. I see somebody has their hand raised. So, Jody, what?
Hi, can you hear me?
Yes.
Okay, I've never gotten to do it like that before. That's cool. Where you unmuted me. My question, and I saw somebody else put something like this in the chat, and I want to say, as a regulator, I think this is first of all, this was super helpful, and at least now I understand, we understand more of what we're looking for on the mill sheets. But what is the deal with people are saying that it's so easy to fake them? You know, we do, the last time we went around and checked, we have about 80 facilities here in our county, and what we've been finding a ton of the wrong grade of steel, and having people put up signs just telling them that they can buy the jewelry, but they can't use it to pierce with. You know, they could buy it once the piercing is healed, but what do you think about that as an argument? Honestly, on the industry side, I don't understand why mill sheets are so important, because I can just Google whatever I want and show it to you anyways.
I mean, yeah, I guess you can fake anything. You know, the thing is, like, there are consequences, you know, when you fake paperwork. I mean, like I said, there are more common mills like Shaw and God, what was the other one that was on the? Hey, Brian, remind me what some of the more common mills are. Where's my?
I feel like now that you said what you said, I feel like now anything that's in Chinese is not acceptable.
That's definitely, oh yeah, Fort Wayne and Shaw are some of the more common ones that you see. They're big producers. I mean, you can reach out, you can contact the mill, which is something that the APP does when they're suspicious, and and ask if they do provide this material. They'll tell you whether that's a material that they even produce.
Mm-hmm. And then what about after the mill sheet? I know we had talked about, oh, my computer's about to die. We had talked about, sorry, I had to plug this in or I'm gonna lose you guys. Shoot, no, I lost my train of thought. Nope, lost it. Sorry. It was something about I don't know. I'll have to keep thinking. If I remember, I'll put it in the chat.
All right. Thanks, Joey.
Thank you, guys.
Some other questions that came in were, do you know of any agencies that are inspecting the actual material manufacturers?
No, I think technically the FDA could if they wanted to. They're not, just kind of like they're not inspecting tattooing right now. Yeah, Perryman, thank you, Brian. Yeah, FDA could have oversight in body jewelry. They just choose not to at the moment.
Okay. All right. Is it possible for non-members of the APP to see the list of approved mills?
The best way to do that, because it's something that's constantly being updated as we find problem manufacturers or have new manufacturers introduced to the industry, is you can send an email to members@safepiercing.org.
Right. And so 14 karat gold or higher is approved. Are there any stipulations regarding yellow, white, or rose gold? Our county does not allow rose gold for initial piercings. Can you elaborate as to why this may be?
For the APP, we require gold to be 14 karat or higher, nickel free, and cadmium free. That's because nickel is a common additive in lower quality white gold, and cadmium can be an ingredient in solder in rose gold. Yeah, as Brian clarified, the APP allows gold that meets ASTM F2999 standard, which has limits for impurities like lead and all that stuff. I would imagine the person that asked about rose gold is there was a time when rose gold wasn't common in the industry, so it wasn't expressly allowed in the APP standards. So yeah, that's something that we revised to clarify a couple years ago, since 2018. Yeah. But I would imagine that's probably where that came from.
Okay. One question is, will the PowerPoint be available? Are you okay with the PowerPoint being shared, Christina?
Yeah, that's fine. I can make a PDF of it.
Okay. So yes, the PowerPoint will be available, and we will also, the presentation, the recording will also be available through the AFTA website, for those of you that have asked that. And what is the website? So it's afdo.org, afdo.org. We'll have the all the webinar trainings that you can see. And so this is similar to other questions we had. What are problems if you don't check mill certificates?
I mean, you just can't verify what you have. You know, you're basically using an honor system.
All right, are there any more questions? Feel free to raise your hand or type it in the chat or question and answer box.
Yeah, like Brian made the point of like, yeah, not having a mill certificate is about like eating food without an ingredients list. You know, and when you have a tomato allergy, that can be a big problem.
Right.
All right, well, if nobody else, oh, somebody did ask, what can you do if they don't have a mill cert?
Yes, I think we've
Well,
answered
they
that
can't pierce.
already.
All right, are there any other questions? Oh, Jackie has her hand raised. So Jackie, go ahead. You're muted if you're trying to talk.
Sorry, I was just scrolling and accidentally hit the button.
Okay. All right. Are there any other questions?
Oh, Laurel.
Somebody asked, do you suspend a permit if there are no mill certificates?
That would be up to each like county's regulations, how they handle that.
Right.
Like for APP membership, for instance, if someone applies and doesn't have like enough invoices of safe jewelry, we just ask them to reapply with more paperwork. You know, I would imagine that's probably how most health departments handle something like that. You know, either tell them they you know need to provide more documentation, or they need to buy more jewelry that is safe to pierce with.
All right. And it looks like Jody has her hand raised.
I know you're shocked, right? Oh, and I just saw my mute button for the first time. So somebody put in the chat, what do you do if they don't have mill sheets? So this is like what you guys are talking about here in El Paso County. I mean, that probably I can't imagine there's anywhere that's not a requirement for a piercing studio. So I mean, if we have experienced this where we have gone in, they don't have the paperwork they need. If they're piercing and tattooing, I'll tell them they can continue to tattoo, but they have to cease piercing until they can provide me with the required documentation. It's sadly, like Christina said, so much of it is on the honor system and those shops where we're going in trying to not devastate them when we're like, sorry, you just bought, you know, $8,000 in jewelry that you can't pierce with, but you can sell it, but you got to put up a sign. It's like all we can do is the best we can. Nobody can babysit.
Yeah. Yeah, and you know, we've like the APP has definitely had to deal with some companies making false claims that their jewelry meets standards for APP membership. And yeah, we've had to send cease and desist letters to a couple of companies that were doing that.
Oh,
You know, that's where like, you know, it's important that your piercers know that they, you know, if they don't see this kind of documentation, then that's a red flag to them that they probably shouldn't be buying stuff from, yeah, from this. Yeah, Brian's got a more in-depth, yeah, we were just trying to talk about documentation today, but Brian has a presentation that he gave recently that's more in-depth into the chemistry and all that.
Great. Oh, somebody asked, can uninspected metals be tested?
If you don't have the paperwork, you have to do destructive testing, which means you have to destroy the piece to make sure it meets standards. So then you can't put it in somebody after that.
All right. Any other questions? All right, excellent. Thank you so much. Oh, here's a question. Do you know of any piercers who were civilly sued for injuries associated with poor materials?
I don't personally, but that could happen. Yeah, that as professionals, we're expected to, you know, follow the standards.
And a follow-up question is, where can destructive testing be performed?
At a laboratory. That's something you can search for materials tests. There's all kinds of there's all kinds of laboratories across the country that do it.
All right.
Sometimes even local colleges have the capability to do it.
All right. Awesome. Thank you so much for the excellent presentation, Christina.
Oh, thanks, Cora.
And like I said, we'll be send the PowerPoint and the recording will be available through the AFDO website. And again, that's afdo.org. And if you have any questions, feel free to reach out. And thank you again, Christina, and everybody for your time.
All right, thanks everybody. I appreciate you listening.
thanks so much, Christina.
Yeah, and I'll get that PDF to Laurel to distribute.
Perfect.